5.5 is maybe one of the easier lessons that we do. So I want you to think about if you're given a coordinate point, A, F of A, could you write a formula? Now, think about if you have a F of A is our Y value, what would the slope be? The slope is just the derivative. So let's call that F prime at A. Then here's your point, here's your slope. So we take Y minus the Y coordinate, F of A, equals the slope, or the derivative of F prime of A, times X minus the X coordinate. So if I want to get Y by itself, I would just add F of A to the other side. So it'd be a positive F of A plus F prime of A times the quantity X minus A. So that's literally just using the point A F of A and the derivative for the slope. That's actually what we call linear approximation. So linear approximation is kind of, if you zoom in close enough to any graph, if you get close enough, it'll eventually form a line. This is just the equation of that line, which leads to this formula. So instead of Y, they just write L of X for linearization. But this is the same formula we just derived. All right, so let's look at this equation. F of X equals the square root of 1 plus X. Anytime you see linearization, line, write an equation of a line, you know you need point and slope. How do I find the point of anything? If we are looking at X equals 0, you just plug 0 into the equation to find its Y value. That's just the square root of 1, which is 1. So the coordinate point we're going to use is 0, 1. The slope we find from the derivative. So first I take the derivative F prime of X, which is 1 over 2 square roots of 1 plus X. Nothing to chain on because the derivative of 1 plus X is just 1. So now we find F prime at 0, because these always have to match. The point and the slope X value are the same. 1 over 2 times the square root of 1, which is 1. So my slope is 1/2. Write your equation. Y minus the Y coordinate equals the slope times X minus the X coordinate. You just, to get Y by itself, just move over the 1. So Y equals 1 plus 1/2. Technically, you don't even need the minus 0. It would just be 1/2 X. And to have it in linearization form, we just replace Y with L of X. And that's it. That's linearization. Don't make this hard. Point, slope, write the equation, solve for Y. This is just an extra practice. Linearization. So F of pi over 2 is just 0. So my point is pi over 2, 0. F prime, the derivative of cosine is negative sine of X. So F prime at pi over 2. What's negative sine of pi over 2? Well, sine of pi over 2 is 1, so this is the opposite. So that's negative 1. That's my slope. Point, slope. So Y minus, and since it's Y minus 0, I'm just going to go to the equals. My slope times X minus the X coordinate. And you can distribute it. You can replace Y with L of X. I'm not going to worry about the approximation. As long as you can get the linearization, the equation, this is the important part. All right. And the second topic is differentials. I want you to think about if you start with y equals f of x and take the derivative of y with respect to x is just dy dx equals f prime of x. What the differential does, technically, it kind of just multiplies by dx. It's just getting dy by itself. Notice dy equals f prime of x dx. All right. So if we look at letter A, you can still start it dy dx equals 5x to the fourth plus 37. Then just get dy by itself. Be careful, you want to have the entire right side as a quantity times dx. So this would be the differential dy. Then we're going to evaluate dy, plugging in 1 for x and 0.01 for dx. So dy equals, well, if I plug 1 in for x, that's just 5 times 1. 5 plus 37 is 42. The dx differential value is 0.01. Just multiply to get 0.42. Take the derivative just like you always do. Move the dx to the other side, plug in your values. All right, that's letter A. Letter B, the derivative dy dx equals cosine 3x. Don't forget to chain on the 3 times 3, so I'm just going to put that in the front. So our dy equals 3 cosine 3x dx. Then I'm just going to substitute in pi. So dy equals 3 times cosine of 3 pi. All right, 1, 2, 3, 4. So that's pi. That's 2 pi. Here's 3 pi. Technically, cosine of 3 pi is the same as cosine of pi. If that's confusing to you, you can just kind of keep going. See how this just came at the same spot? This is just -1. The value of dx, negative 0.02. So this is going to be a positive. Positive times negative. Then 3 times 1 is 3, times 0.02 is 0.06. So that's when you evaluate. You're going to have to be able to find dy, and then evaluate. Those are the two things you've got to do with your differentials. All right, so let's look at C because that's good practice. Because if you notice letter C, that's implicit. So if we take our derivative of x is just 1, derivative of y is dy dx, equals xy is a product. So I take the first times the derivative of the second, plus the second times the derivative of the first. Then I just want to get my dy dx's on the same side. So I'm going to keep this one on this side. Subtract my x dy dx equals, I'm going to keep the y on this side, but I need to subtract the 1 to move it to the other side. So everything on the left has a dy dx, everything on the right does not. So factor out dy dx, then you get 1 minus x equals y minus 1. And I'm going to just divide by 1 minus x. So then my dy equals the quantity y minus x, 1 all over 1 minus x times dx. Now, if we're given the value where x is 2, how would we find the value of y? Well, we are given an equation, right? So can't we just plug it back in? So this is a little sloppy here. So if I plug 2 in for x, I get 2 plus y equals 2y. Then I can subtract y. So then I get 2 equals y. So y is 2, x is 2. So when I evaluate, substitute in 2 minus 1 over 1 minus 2 times the dx value of 0.05. So dy equals 1 divided by negative 1 is just negative 1 times my decimal. And that's just good practice on implicit plus evaluating. And I don't think we really did much else on the other ones. So that is all. That's all we did. Just do the homework that applies to that particular lesson or those examples.